I'm going to talk about trigonometric equations. There are several techniques for solving various types of trigonometric equations. I'm going to show you two techniques. One of them is going to involve special angles, and the other one is going to involve the arccosine, arcsine, and arctangent functions. All right. So here is an example of a trigonometric equation. Suppose we wanted to solve this equation. So we know that x represents the measure of an angle. So this equation is asking us to find angle measures such that the sine value is 0. So hopefully you can see that x equals 0 is a solution. Okay, but notice that it's not the only solution. Pi radians is also a solution. Negative pi radians is another solution. And 2 pi, 3 pi, minus 2 pi, minus 3 pi. So we've got an unlimited number of solutions. So 0 radians plus or minus pi radians plus or minus 2 radians and so forth. All right. One way to compactly describe the solution set is the following. X is equal to n pi, where n is equal to some integer. Okay? So you will often see this situation where you've got several solutions to a trigonometric equation you're focusing on, okay? And often you'll have an unlimited number of solutions, okay? Now, this trigonometric equation was able to be quickly solved because it involved a special angle, okay? Let's do another example that involves a special angle. Suppose we wanted to solve this trigonometric equation. The cosine of 3x equals the square root of 2 over 2. So we need to find an angle measure such that the cosine of that angle measure is the square root of 2 over 2. Now, and that angle measure is what 3x is equal to. Now, you hopefully know that one solution is pi over 4. All right. Now, again, that's not the only solution. You can actually have minus pi over 4 as well. So why don't I put a plus or minus in front? And furthermore, we can add or subtract multiples of 2 pi and get other solutions. So the solution set that includes all the possible solutions is plus or minus pi over 4 plus or minus 2 pi n, where n is some integer. Okay? Now, however, we're not done yet. That is what 3x is equal to, but our goal was to find what x is equal to. So let's divide both sides of the equation by 3. Okay, so there you have it. X is equal to plus or minus pi over 12 plus or minus 2/3 pi n. All right? Now, let me show you how to solve a trigonometric equation that does not involve a special angle. Suppose you wanted to solve the tangent of 7x equals 0.12. Now, this trigonometric equation is not associated with any special angles. However, here is one way to get a solution. We know that the tangent of the arctangent of 0.12, whatever that is, we know that that is equal to 0.12. So apparently the a solution is the arctangent of 0.12. So let's write that down. 7x equals the arctangent of 0.12. Now, we know that if we add or subtract some multiple of pi to an angle, it won't change the tangent value. So we can get a more general solution by adding n pi, where n is some integer. Okay, but we're not done yet. That is what the right side of the equation is, what 7x is equal to, but we need to find what x is equal to. So let's divide both sides by 7, and we'll get 1/7 the arctan of 0.12 plus pi n over 7, where n is an integer. Okay? Let's do another example that does not involve a special angle. Suppose we wanted to solve this trigonometric equation. 1 plus the sine of x is equal to 1.3. So let's first isolate the sine of x. We'll subtract 1 from both sides, so sine of x is equal to 0.3. And that's not associated with the special angle, as I said, so let's use the fact that the sine of the arcsine of 0.3 is equal to 0.3. Okay, so x is equal to the arcsine of 0.3. That's one solution. And to find all the solutions, let's think about the unit circle. So I can add or subtract a multiple of 2 pi and get and the sign value won't change if I do that. So plus 2 pi n, where n is an integer. Okay, but we are not done yet, because suppose you wanted to know another angle that had the same sine value as 10 degrees. Would you agree that 170 degrees has the same sine value? So my point is that if some angle has a certain sine value, pi minus that angle in radians has the same sine value. So we have to account for those solutions. So x can either be that, or x can be pi minus the arcsine of 0.3 plus 2 pi n, and that of course is also for n equal to an integer. Okay, so this solution is a little bit more complicated than the other ones. Notice that in order to solve trigonometric equations, you have to understand how the trig functions relate to the unit circle really well, and how the sign values change as you add or subtract multiples of pi and 2 pi. Okay? Now, let's have you try to solve a trigonometric equation. Please try to solve the tangent of 2x equals the square root of 3. All right, so pause the video and do that now, please. All right, so this one involves a special angle. 2x can equal pi over, let's see, that's this, we want 60 degrees, which is equal to pi over 3. By the way, you don't need to always present your solutions to trigonometric equations in radians, all right? But radians are one way that people present solutions. Okay, so there's one solution in radians, pi over 3. Now, other solutions can be found by adding a multiple of, an integer multiple of pi. Okay, and so now let's divide both sides of the equation by 2. And there is our final solution set. X equals pi over 6 plus pi n over 2 for some integer n. All right? Let's do one more. Would you please solve the cosine of 5x equal to minus 0.86? So pause the video and try to solve that now, please. Okay, I'll go ahead and solve it as well. So this equation is not associated with any special angle, so we might consider using arc cosine, but there's a problem. The cosine of the arc cosine of minus 0.86 does not equal minus 0.86. So why is that? Well, recall that the sine, cosine, and tangent functions are not invertible with respect to their entire domain. So the best we could do, which we did, was define functions that behaved as inverses for limited domains. Okay, that's what the arc cosine, arc sine, and arc tangent functions are. Because of that, the arc cosine, arc sine, and arc tangent functions have limited ranges. Okay, there is no number for which you can take the arc cosine and get a negative number. The range of the arc cosine is with respect to values between 0 and pi. All right, so if you want an angle measure whose cosine is minus 0.86, you would be better served using this one. Pi minus the arc cosine of positive 0.86. Okay? So think about why that works. Okay? And so we'll set 5x equal to that instead. Now, that is only one solution, so we've got to find all the solutions. So let's think about this. Well, we know we can add some multiple of 2 pi. All right, so there's more solutions where n is an integer. Okay, now in addition to subtracting arc cosine from 0.86, in addition to subtracting that from pi, we can also add it to pi. And that'll also be a solution. So we're going to want to change the minus sign there to plus or minus. Okay? So as you can see, you need to know the unit circle, how the sine, cosine, and tangent functions relate to the unit circle really well. All right, so let's see. We've got a pi term and then a 2 pi n. Why don't I do this? Why don't I combine those two into a term that looks like this? Pi times 2n plus 1. Okay? Just a little bit more compact. Now, we're still not done because we have to divide by 5. So let's do that. Divide both sides of the equation by 5. So we get plus or minus 1/5 times the arc cosine of positive 0.86 plus pi times 2n plus 1, where n is an integer. Okay, and so as you can see, this one was a little bit more involved, but that's sometimes all that you need to do to get all these solutions.